Hello and welcome. This is Timothy Thor Mullen, and this is a re-recording of my Hash Days session. Hash Days was held in Lucerne, Switzerland in October of 2011, just a few days back. And during the session, I missed a couple of points that I wanted to make, and I also like my own environment here where it's more conducive to the demos that I want to run, and that's kind of the important part of the presentation here. Before we launch into it, I would like to say thank you to the Hash Days guys. They did a great job. If anyone watching this hasn't been to Hash Days, you should really plan on going next year. The guys do a great job setting everything up, and it's a valuable conference. The theme last year, or this year, it was actually risk management, and the purpose was to give attendees the tools and knowledge that they need to actually address security concerns, to actually act on some of the issues that we face today in the security industry. And that's relatively unique, and the reason I say that is because many of these bigger security conferences kind of focus on the attack side of things. Everything's all about razzle dazzle and showing how to pop boxes and how to do things, but it doesn't provide anyone with any information on how to prevent these attacks. And that's really what I'm all about, and I think that's what the industry should be about. And I think it's a failure of the industry, so I'm really glad to see the Hash Days guys doing what they're doing. So anyway, let's kind of launch into this. As I said, this is going to be a session kind of revolving around TGP, Thor's Godly Privacy, of course, tongue-in-cheek acronym for my encryption utility, which is designed for use in the cloud. Of course, everyone's all in on the cloud. Everything's moving that way. Cloud is a ubiquitous term. But for the most part, it basically means somebody else's servers that you're storing your data on. And I know that's an oversimplification, but as far as we're concerned, we're going to stick to that. So what TGP is as the name kind of infers, it is kind of derived from the PGP program, except there's a couple of things that make TGP different. First off, I don't think it sucks. PGP is, I don't know how it happened, but it looks like it was written by a 12-year-old. If any of the viewers are programmers for PGP, I guess you couldn't not take that in a bad way, but it's not my fault that you don't know what you're doing. Anyway, let me kind of show the interface here. This is going to be a little different than in the presentation because I am here, and I kind of wanted to be able to show you things live. And let's just launch PGP. I'm going to continue with, and if I mess up or sound like an idiot during this presentation, I'm not going to stop. I like to look like an idiot live. So we'll just bring up the interface here. Basically, TGP in its simplest form is a PKI encryption solution, meaning a public key infrastructure, in that I will create a key set which will consist of my public key and my private key. In all cases, public keys are used to encrypt data and private keys are used to decrypt data. So as in a standard PKI paradigm, I can share my public key with anyone I want, and I'm the only one who keeps the private key, and then that way people can encrypt data for me, and I'm the only one who can decrypt it. So kind of what makes TGP a little bit different is the format that this data exists in. So I can show you an example here. There are basically two types of data. We have a key fob, which contains the key material, and then we have the encrypted data blobs, and I'll show you those in a second. So the key fob, as you'll see, is tagged in XML. So that's one of the main differences, is that all of the data elements are encoded within XML, and that allows you to be able to automate consumption of this data, which I haven't seen any applications that allow you to do that. I had a particular use case that I'll be explaining later on in the session for this. And so you'll see I have basic information, some key fob names. In this fob, since it is a private key fob, or this fob contains the private key, you'll notice that there is no public key data. The public key is actually derived from the private key data insofar as the .NET implementation of the RSA encryption objects are concerned. I have a key hash and a key salt. Best practices of encryption would dictate that anytime you create a encrypted set of data that you add a salt, and that salt should change every time. The salt is considered public information. I guess some people consider the salt private, but that's not the standard use case. So I include the salt here, which of course is necessary to combine whenever you derive bytes from a password in order to decrypt the data. So what you'll see is this is actually an encrypted private key. This might seem a little counterintuitive, but basically this is all of the data that I need in order to decrypt data specifically for me, where my public key was used to encrypt it. So this is actually an encrypted private key, and it is protected with a passphrase. So it's kind of a multi-step process. I will retrieve my key fob, I will enter in my passphrase to decrypt the encrypted private key, then the private key is accessible for me to be able to then decrypt my data in TGP. So let's just take a look at the actual TGP data itself, and I'll come up here. Let me just pull up my text file. So here's your standard Latin text. You'll see whatever that means. I have actually no idea what that means. It could be something very vulgar, and here I am displaying it on my screen. And what I'll do is, just to kind of show you this, I'm going to load a key pair, and in this case I'm going to load my private fob. Oh no, I don't want to do that. See, already messing up. I want to load, and I'll just load this one. Oops, and that is the wrong password. Okay, so I have loaded this key fob, and we'll see here the load was successful. The key status is that I have the full key pair, which means I can encrypt and decrypt. If I'd loaded a public key, all I would be able to do is encrypt. And so the private key allows me to do both. So what we'll do is I'll come down here and I'll select that text file, TGP text, and it automatically fills in all the data that I need. And it's going to create a TGP extension, and I'm going to say OK. So that's that. So I have encrypted that file. So let's just take a look at that. There it is. So in the same way that our key fob data is encapsulated in XML, the encrypted data is also encapsulated within XML. And so we see the key name here is shite, which I guess might be construed as vulgar. The hash of this key, in order to determine validity of the key to make sure nothing was tampered with. A public hash, which is a hash of the public key data. And the reason that I do this is that I want to ensure that I have a hash of the public key that was used, as well as the overall entire key on my side, in order to validate again that this data has not been tampered with. Here we have the encrypted AES key, and you'll see that this is a relatively substantial amount of data, along with the AES initialization vector, and this is the crypto blob. The crypto blob actually contains a base64 encoded representation of the encrypted binary data, a resultant encrypted ciphertext of what we saw here, and this guy, right? So Let me explain this for a minute. You might be wondering, AES, I thought this was PKI. Though, if you're not familiar, all PKI encryption paradigms will use a combination of RSA, asymmetric encryption, combined with AES or whatever the actual pair. It could be elliptic curve. It could be a number of different things. However, from a paradigm standpoint, what is done is a RSA encryption object, depending on the key size, is limited in the amount of data that it can encrypt because it is an asymmetric encryption algorithm. So with a 1024-bit RSA key, you're limited to about 117 bits of data, almost twice that for a 2048 key length in RSA. So given the restriction of the amount of data that can be encrypted with that particular cipher, what is done is that a random cryptographically strong AES key is generated. The RSA encryption object is used to encrypt the AES key, and there's the AES key that is used to actually encrypt all of the data. So there's no limit since it's a block cipher, and it's symmetric, meaning that the same password or key will encrypt and decrypt. Asymmetric is that you will encrypt with one key and decrypt with another. So what happens here is my public key is used to encrypt the AES key. The AES key is static, and that will be used to, it's different each time, of course, but the AES key is then used to encrypt the data that's reflected here in this crypto blob. And then whenever I decrypt this data, I will use my private key to decrypt the AES key, and then once I retrieve the AES key, I use that to decrypt the actual crypto blob data. And so again, we see that that this is all base 64 encoding, and that gives me the opportunity to post this data anywhere that I want. I know we haven't quite gotten to the cloud paradigm yet, but I'm just kind of preparing you for this by way of explaining what the basics are here. So now we have our encrypted data, and decrypting it is a factor of doing the same thing. I'll come up here, I want to decrypt. I will select the TGP text TGP file, and you'll notice that it automatically goes back to the TGP text. I'll say OK. In this case, bam. So that pulls that guy up and shows me the decrypted data. Pretty cool. So let's get back to the presentation here to see if we're missing anything. So with the hands-on overview, so we've showed the structural overview of the fob and the TGP, some of what the logic flow is. Again, we basically will load a key, encrypt or decrypt, and then we're good. Again, what makes TGP a little bit different, I've talked about the XML structure. It's always in a fully postable ASCII format. That means that this data can be sent in an email. More importantly, this data can be posted to a social site. This data can be included in any sort of listserv, forum, anything like that. You don't need to be an administrator to execute this. These other installation programs require you to be an administrator, which I personally don't like. They also require an installation. You don't have to install TGP. TGP uses the .NET client profile libraries that are included as part of Windows. So you can actually directly execute from a thumb drive. You can actually launch it from the internet, so you don't even have to have the program resident on the system that you're running it from. The key files are stored individually rather than a database of let me reload this guy. What that did was told me that the TGP text file was altered while it was up, and if I wanted to reload it, and I said yes, and of course it's the same thing because it's the same decrypted data. So we'll see that the fobs here are all individual files. PGP, and I believe GPG as well, the open source, will load all of the keys into a single file. like kind of in a database format, and then you have to retrieve them out of that, but there's no portability for those files. They're also in binary form, so you can't transport them, or you can't post them very well in other places on the web. Hopefully this will become more evident in a moment. The other difference is that TGP is fully integrated with the Windows certificate store. So in a PGP GPG paradigm, the PKI infrastructure is all based on peer-to-peer trust. You don't really know that I'm the one who created the key. I can give you a thumbprint or a hash of that key, but you don't know that I'm actually the one who created it. You have to trust that the key came from me, which kind of goes against the whole purpose for PKI. Here, if I don't want to load a key pair that I've created myself, but I want to load an X509 certificate that was created by some certificate authority that I trust, and there's a whole chain, I can load these guys, and you'll see all of my keys pop right up. Zune, Thor, what have you. And so I can use those keys to encrypt and decrypt. So if I have public keys that are created from a PKI infrastructure based on certificate authorities, then I can take full advantage of that here. And I think that that's actually quite cool. I don't know any other utility that does that. Microsoft actually doesn't have a peer-to-peer encryption utility here. They have different ways of moving files about via email and EFS and things of that nature, but they don't have a standalone PKI-based system. I've had a number of requests for the source code. It's kind of interesting, the expectations some folks have. They're like, well, how do you actually expect me to install this without being able to look at the code? And not to sound flippant, but I don't expect people to do anything. If they want to install it, they can. And if they don't, then don't. If you don't trust my code, by all means, don't install it. However, what I think is funny is anyone who would have the capability of analyzing the source code to determine if there was any nefarious activities, or just to ensure that I was following proper procedures in the encryption process, would know that in .NET code all you have to do is use Reflector, and you can take a direct look at what the code is. So I always find it funny that some of these open source crybabies are asking for something that it's clear that they don't know what to do with once they got it. So I find that kind of funny. So that's kind of the brief explanation of what TGP is. You'll see some more on it. This isn't supposed to be a session about TGP specifically, but its application to the cloud here. So what we have is today's paradigm is primarily we take measures to control access to the data. The value lies in the owning of the data. Whoever owns the data owns the value. Whoever controls the data controls the value. And the firewalls we set up, the ACLs that we have in place, the authentication infrastructures that we have, and the distribution of the data, separation of network assets, all of that is done to control access to the data. The data owner is responsible for all maintenance and costs. And typically, insofar as encryption of this data is concerned, there's no functional separation of the key material and the encrypted data. Meaning that you'll see in this small illustration here, we have the user and the server. The server will retrieve a key, which is typically stored on the server itself, and then encrypt the data that's stored in the database, and then it will decrypt that data and present it back with the user. This is extremely common, and in fact, by necessity in some cases, because people don't have an effective key management infrastructure. Of course, the obvious issue here is that a compromise of this server will yield the key data. So almost in all instances, and it's typical during penetration testing, whenever we have people following PKI requirements, they will encrypt credit card data and what have you. But of course, the server encrypting the data has to have access to the key, and the key is typically stored right there on the server. And in some cases, people store it in the either a text file or in the source code itself, which is ridiculous. And so that key data is immediately available. If I pop the server, the encrypted data really doesn't help much. I'm going to move this guy here. Now, in the cloud paradigm, ultimately you cannot control who has access to the data outside of whatever design controls are made available to you by the provider. So, in a public cloud infrastructure, very much like in a shared, like your ISP or an application service provider, you have multiple customers sharing data here in the cloud, sharing resources, server resources that the provider has, and you don't know what separation of data occurs, what network segregation exists, whether or not your data is stored in a different database, whether or not it's on a different server. You don't know. You can trust that they have particular controls and access controls in place, but you don't know. To protect the value of the data, what we have to do now is ensure that access to the data does not grant the controller of the data the value of the data, which is different than our current paradigm, right? Because the data, once it exists, as we see here, even in cases where it's encrypted many times, or whenever I compromise a data center, then I control the data and I have the value. In a cloud paradigm, we have to ensure that the data, access to the data, does not give access to the value of the data. And that's going to require encryption, and it's going to require intelligent encryption. And this is kind of now we're starting to get into where TGP and a accompanying product and API I have that you'll see shortly kind of comes into play. To consume true cloud solutions, you have to pay to play, meaning that in the same way that I have to purchase server resources and what have you for my infrastructure, I have to pay for my cloud services as well. However, if you're sneaky about it, and this is not from a corporate standpoint, but for individuals, if you're sneaky about it, you can actually offload costs and accountability of the data to third parties while you're maintaining security. I'll show you that in a sec. And it's typically the same encryption model, where since you have a cloud, and in some cases it's even more pronounced in a cloud paradigm, the encryption key data is stored somewhere within the application that's encrypting the data, and it encrypts and then decrypts, and the same sort of model holds true. Compromise of the server yields compromise of the key. So let's take a moment here to kind of demo what I mean by being sneaky about moving your data around. We're going to, let me just do a standard file. I showed you the encryption. I do want to show you kind of quickly. I'm going to create a new key pair, and so you'll see. I'm going to give it a name here. Test. This is important. Key size 2048. TGP actually ensures that you are aware of the strength of your password. Password strength and complexity are ambiguous metrics. They don't mean anything. Is your password strong? Yeah. What is complex? What does it mean? And more importantly, does complexity infer a particular level of security? And as it turns out, it actually doesn't. So I can have a passphrase here, capital I, splat, little 1 3 5. So here we have a 6-character password. What I do here is based on a class F cracking of 1 billion per second. We've designed an algorithm here with the help of my friend Will to determine the total number of iterations possible for the password. In this case, it is 91 trillion, and it will take 91 seconds at a class F to crack the this particular password. So this is not the total key space. Total key space we'll see is 195 trillion, and the seconds to crack the entire key space is 195 at a billion per second, of course. So what the algorithm does here is it actually will determine how many iterations for this particular password and then how long that's going to take to crack. So you'll see I don't even remember what I typed in, right, because it's complex. So, but if I put my name is Tim, which is extremely easy, now we go from 91 seconds to 548 hours. All right, so it's all in the length, and I do some tricks on how I derive that, which you can look at online at Hammer of God on the TGP site if you want some more information on how this is happening. But so what I basically wanted to show is I'm going to retrieve a key. So about a year ago we were having this discussion, and I posted my key, a key, on full disclosure. And there were some people who were saying they'd be able to decrypt it in a day, and of course it hasn't happened because they can't. So no matter where I am, so I'm going to find my key. I'm going to say Thor private key. Full disclosure, my private key. Pow, here it is right here. So it's the first, it is the first search result listed. I'm actually going to come down here. You'll see I've gone to this one before. And so here's my private key, and you'll see that I posted this June 11th of 2010. So this is my private key. I'll explain later. I can take this key data, and you'll notice this is on Gossamer Threads, whatever that is. The interesting thing here is that my key, and it's protected by a passphrase that only I know, but you're going to know it in a second because I'm going to tell you, so you can test this yourself. The storage of my key is not up to me anymore. I don't have to worry about storing this key. I don't have to worry about access to the key. Once I post it on full disclosure, it is replicated to many different lists, backed up, propagated throughout the internet. I never have to worry about paying for the data. I never have to worry about being responsible for the data existing. If I had something questionable, which of course I never do, that I wanted to encrypt but have access to, I could very easily post that data and count on other people to store it for me and to back it up for me, and I will have it available anytime I want. And I think this is a very good example of that, because it's been over a year and a half maybe, and here's my data, and I have ready access to it. So if I come up here, what I've done is I posted it here, the KUNV, you'll see here. I've posted this data here, and I broke it up nicely. You'll see if I just paste it, it's kind of a little messy, and for whatever reason the backspace slash didn't come in there. I'm going to undo those changes, but you'll see that's the same. That's the I'm not going to, yeah. So we have that key data. Now what I want to do is go to Facebook. I probably shouldn't show you this. And I'm going to look for a friend of mine whose name is Poon Tang. It's an interesting name. And so let's see. I'm going to, actually I believe I sent him a message, and there it is. Oops, that's from Steve. Sorry, I don't want you to see all this. So, right. So here we have a message that I sent to Poon. What I'm going to do is select all of it, which that's not going to work. Let me come up here. Facebook sucks. They could make it easy, but they don't. Why don't you make it easy, Facebook? This is actually pretty cool. Copy. So I'm just going to copy this data. It's all in, and you'll see it still has the tags. I'm going to create a new file here. I'm just going to paste that data into it. Paste. So here is the data that I had posted on Facebook, and I'm going to save it. And I'm just going to call it hashdaysdemo.tgp. And so now I'm going to load the key fob, the full disclosure fob, and the password is I_your_mom. Ooh, that sounds dirty, doesn't it? Yep, loaded that key fob. And so now I'm going to decrypt the file that we just created, which is not there. Hashdaysdemo. Oh, TPG. Sorry, that was stupid. And I'm going to, I know it's a spreadsheet, and I'm just going to call it XMLS. I'm going to decrypt it, and then, actually, let me do that again. Decrypt, because I want to, you'll notice that the actual file extensions don't matter. And what you're not seeing over here is I lied. I did pause it. And that's because I forgot the extension of an Excel spreadsheet. Sorry. We're all only human. So let's just do this again. I'm going to decrypt the hashdaysdemo file, and I'm going to select the hashdays XLS spreadsheet. I'm going to replace it, and I'm going to say OK, and then bam, what we do is we load my secret data and what have you. So this is the file that I posted on Facebook, and the key was retrieved from full disclosure. So what I find very interesting, this is analogous to cloud encryption, is that I can store both my encrypted key data and my encrypted file data elsewhere in forums where I don't have to pay for it. I don't have to be responsible for the content of the data, which is a very interesting concept, and I don't have to maintain the data, and it's going to be here forever. I very well could have just posted that spreadsheet to full disclosure or DSL reports or somewhere else, and it would be there forever and ever, and anytime I needed that data, I could be in Bangkok and go to a web cafe, pull up the key file data, and then dump it directly into TGP. You'll see, actually, to show you that, a key drop box where I can just drop the key directly into the executable that I can launch from the internet. So there's some very interesting aspects to this, and I think it's worthy of your consideration to how you can leverage different paradigms to distribute and store your data. So let's get into a little bit more detail with specific cloud solutions. Our effective cloud solutions are going to require, it really requires, I say depend upon, robust key management and encryption models. We need logical and physical separation of key material from the encrypted data so that instances like this cannot occur, because we don't want a compromise of the server to yield the key that then yields the data. What we want is to physically separate the key data from the encrypted data. As such, we will need a flexible authentication infrastructure. We will need to be able to create an access environment to where different users will have access to different keys in order to decrypt different sets of data. Let me jump forward here to a quick model. So what I've done is written a API called Rainmaker. Hammer of God, thunder, cloud, Rainmaker. It worked in my head, sorry. Where what we'll do is, let me kind of define what we're looking at here. We have our cloud services, which could be anywhere. We have the Rainmaker APIs, which is what I'm providing, or what you could run on your servers, or in fact a different cloud provider. So the user will request data from our cloud services. In this case, we see that the encrypted data is tagged within XML, very similar to the TGP files that I showed you earlier. We have a crypto blob here, but we also have plain text, data that doesn't need to be encrypted, that we don't care if people see, but embedded in here is a crypto blob. And of course, since it's all within XML, it is very easily parsed out programmatically. This crypto blob data will identify particular key material that's required to decrypt it. This key material will be retrieved from the Rainmaker API. The key will then be used to decrypt the data. And here what we see is it's an IP address, very common thing to store. The options to decrypt or to secure the keys that we have here are varied. I very well could, this would be all in an encrypted call over SSL. I could base my delivery of the key on the authentication request, the source of the call, a number of different things. I could have a certificate from the cloud services. We could have any number of identifying criteria that validate the call, and I could either deliver the key itself, or as you saw with TGP, I could require some sort of secondary encryption mechanism or decryption mechanism. The problem that we get into with protecting keys is, you've seen that I've actually encrypted my private key. And so I decrypt the encrypted private key with a passphrase, and that decrypted private key is then used to decrypt the AES key that's encrypted within the crypto blob, and then decrypt the data. So we find ourselves tumbling down this rabbit hole. At some point, you have to stop protecting whatever it is that you're using to protect whatever else came before in the model. And that's where we have authentication infrastructures that will validate the access to the key. So I very well could protect the key that I use to protect the key, and blah, 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 but you find yourself kind of concatenating logic together, and it becomes unworkable. So in this case, in this example, rather, we are using authenticated calls to deliver the key, which is better still than this environment. The key itself is not readily available. They would have to break down through the code. They would have to do a number of, you might say, well, if I own that server and that server is the one making the call to the key, well, the user is actually the one making the call to the key in this case. So you've still separated logically and physically. So they'd have to own the server and they'd have to own the user. You've made it very, very difficult for an attack to be successful here. So we retrieve the data from the cloud services. We retrieve the key data from the Rainmaker API. Then we decrypt the data, which is consumed by the user. So the other interesting thing here is that the data access can be granted on a many-to-one basis rather than a one-to-many basis that the peer-to-peer PKI normally requires. I'm the only one who can decrypt my data. So I can distribute my public key to everyone in the world. They will encrypt data for me, send it to me, or I consume it from some resource, and then I'm the only one who can decrypt it. Well, with a API and a key management system such as this, is I can determine who has access to this key in order to decrypt the data. So in the Facebook paradigm, I could have all of my friends, and in fact, I can use Facebook's authentication infrastructure of friends programmatically to give my friends access to that key. So I could write a plugin for Facebook, and which I am, and use the Facebook authentication infrastructure to gain access to key material. So all of my friends can get the key to decrypt whatever it is that I post on Facebook, and they're the only ones who have access to it. Now, once they decrypt the data, they can do whatever they want with it, but that's consistent for any encryption paradigm. So that's the interesting thing. We can have many people accessing the same key to decrypt the data. In fact, we can have that key encrypted multiple times to where only they can decrypt the record that's associated with that key just for them. And then that way, if they compromise that key, they won't be able to use it continually, which is also very interesting. So I can control access on a user by user basis and have multiple records within my key API that I can control who has access to the key to where they can decrypt that data. But if that user is compromised, I can delete their record. I can do whatever I want. So it's really very flexible, and I think that's cool. So imagine, so based on that, right? Imagine a system where we have access to key data rather than ACLs that are associated with the file structure. The only way ACLs work is it's just the operating system will look at this metadata associated with a file and say, does this guy have access to it? Yes or no. If you dive into the SDDL in Windows, you'll see that it's a very simple text-based nomenclature where it says what SID has access to what data. That's it. And so it's obviously a collection of SIDs for files that have many users have access to those files. But imagine if what we did is rather than distribute ACLs, we distributed keys. And I think it's very interesting, particularly from a database standpoint. Some of you might be thinking, yeah, this is great for file by file, but what about a database where we have a single record? And that's where it gets tricky. And that the solution could very well be, I don't know this, it's just an idea that I have, I need to look at it a little bit more, but it'd be to kind of change the ACL paradigm to extend to key data rather than strict ACLs, and I think that's pretty interesting. So let's do a demo of this. I'm going to kind of branch out a little bit here because in order for this to be effective, what we need to do is illustrate the capability of consumption of encrypted data across different platforms. So this is actually quite cool. I've written TGP Mobile. Let me get rid of this. Which you'll see I have a breakpoint here. So I'll show you that in a sec. What TGP Mobile is an actual Windows Phone version of TGP that, if it will ever load, you will see. There we go. What we have. What happened? What we have is a Windows Phone version of TGP that will allow us to decode data that was encoded on the PC. And as far as I know, this is the only application that does this. So let me run TGP Win here real quick. I think this is pretty cool. And so in this example, I'm just going to use AES. And the reason that I have a breakpoint is because I want to convert it to base 64. The current version of TGP actually stores AES encrypted data in binary form because I wanted to kind of save disk space. I'm gonna change that. It's actually changed in this version. So I'm going to AES encrypt. And so let's do a you know what? Let's just change the data. I'm going to have a TGP text 2. Let's get rid of that. That's vulgar. So we will just call this Merry Christmas, just to make it simple. I'll save that. Bada bing. And let's just make sure. Let's reload it. It says Merry Christmas. TGP2 text, Merry Christmas. That's what we have. And I'm going to get rid of this so as you people don't see my yikes. You don't see any of my posts because that's personal stuff. Like I care. Okay, so I'm going to choose that file, TGP text 2. and then I'm just going to create the AES file. However, I got this breakpoint. Here's the passphrase. I'm going to choose a crappy passphrase. You'll see that it takes 0.0008 seconds to crack with a 5-character passphrase. And I'm doing that for a reason you'll see in a sec. I say OK. So what I want to do now is I'm going to take that memory stream. So I've encrypted this data using a crypto stream to a memory stream based on an AES object. And now I'm just going to convert that to a base 64. And let's see what that guy is. So here we have this. Here's that base 64 string. Now, the Windows Phone implementation is a little tricky because we don't have a file. We have a isolated storage that we can use, but you have to get the data there somehow. So typically the model is going to be that you reach out and grab that data either via a web service or what have you. So I'm going to synthesize that here by going into a file that I store on the web. I'm just going to save this guy, and I hope that refreshes. And let's go back to our TGP mobile. So basically what I did was I went to my web server and I stored that file. Okay, that might seem like it's cheating a little bit, but what I want to do is make this demonstration kind of simple. So I will go to my Rainmaker API. I'm going to change this. See, as you see, everything. I can't even use my keyboard, right? So maybe this makes a little bit more sense on why I did it like that. .txt, because it's kind of a pain. La la la. Go. And it's super tiny. Sorry, that's just the way that is. But I'm going to take this data. I'm going to copy it. And let's go back here. Oops. And run that guy again. Oh, it's going to be gone, isn't it? No, I think it's still there. Paste it. So there is that data. I think I grabbed it. Something happened. It didn't give me all of it. 6 VW dash dash. So the equal did not show up. Boy, this isn't a very great demo. And decrypt, and there's Merry Christmas. So the reason that we had that little hiccup here is because whenever I downloaded this data, I couldn't copy all of it. The interface is not designed for this. I would have a web service that consumes that data. However, the point I think is made that we can encrypt data on the PC and then decrypt it on the phone. Now that was just a very simple. That was just to show you the cross-platform. Here's where it gets interesting. The Rainmaker API is basically a web service that exposes a couple of different methods. Get and private key, get key fob, I have is alive, and I have post keys. What this allows me to do is create keys from either the phone or the PC, post those keys to the Rainmaker API interface for later retrieval. And the permissions on that are based on Windows authentication and credentials, and the key is tagged to the individual keys are tagged that will allow me access to those based on an authenticated call. So check this out. I'm going to do the same thing here. Let me pull up the TGP text. You'll see it right here. So this is the text that I'm going to transfer from my web service, right? So imagine that this is the same file that I did for Facebook, right? So I've posted my encrypted data to Facebook, and what I want to do is from my phone, I will consume the encrypted data, but I don't want to store the key data. I want to ensure that the key data is stored separately, so if I lose my phone, people won't be able to immediately decrypt that data. And as you saw, whenever I loaded my key fob, so again, when I wanted to load the key fob from full disclosure that I posted, let's just say load key fob. Here, I pound your mom, and it was nice. So I needed the passphrase to derive the bytes necessary to generate the AES key to decrypt that RSA private key, and that passphrase is still going to be required on the phone. So it's kind of in order to decrypt the data, I could put in my passphrase, but it's based on a key that doesn't exist on the phone itself. So back to that, let's start this guy over. I love this stuff. So these are just typical crypto. I'm going to go to my Rainmaker API again. Why are you doing this to me? La la la. And go to my Rainmaker API, and this time I'm going to my web source. I'm going to pull that text file. And you'll see, of course, it's super, super tiny, and I'm sorry, even with my glasses on, I can't read this, but what I'm going to do is copy this data. And this is just a factor of the emulator interface, right? I'm going to go down here to my crypto blob and paste that data here. So now you can see it a little bit better. So here's the crypto blob data. Again, this is the data that was transferred to the phone via my web service here. And so now what I'm going to do is come up here to retrieve my key fob. Bam. So what's happened here is that I've analyzed the data within the crypto blob that was retrieved from a web service or whatever source I want. Again, it could be Facebook, it could be anything. And I have analyzed that crypto blob data to determine which key is necessary to decrypt it. I retrieve the key here on my mobile device, which was generated on the PC, from an API. And now if I wanted to decrypt that data, I would have to put in my passphrase and then decrypt that data. I think this is really, really super cool. The capability something like this offers us is required for true security in a cloud environment, as far as I'm concerned, and that's to be able to have robust control of key material access from multiple sources on multiple platforms. I think that's very, very interesting, and I'm actually using this in production at work in a couple of different environments. So we see here that we've discussed that model, showed you the interface, and remotely access the encrypted data on the PC. So that is that. Some of the resources that you'll have for the TGP product itself is Hammer of God TGP. My Facebook page, which I don't know why you just can't put Hammer of God. You have to put whatever this stupid URL tag is here, and of course my direct email, Thor at Hammer of God. If you have any questions, this Rainmaker API is going to be made available. I've got some work to do on that, but in general, what I hope that you've seen here is that I've given you some food for thought on how you might go about securing your encrypted data in a cloud environment in a way that offers robust authentication infrastructures to access the key data, that gives you separation of the key data from the encrypted data, and allows you one-to-many a one-to-many relationship to where multiple people can access the same encrypted data without sharing the same private key, which is very cool. So, thank you very much for your time. And again, I'd like to thank the Hash Days guys for giving me the opportunity to share this data. And I hope that you found it useful. Thanks.